Hello, Chemistry 11, and today's the second lesson in the matter introduction. And what I wanted to do was focus on some characteristics of matter. All right, now, if we remember from the last lesson, when we talked about pure substances, what happened is that it had a unique set of characteristics. Okay, regardless if they were elements or compounds. Now, one of the characteristics that we want to talk about is the fact that pure substances have a unique cooling or heating curve. So what you have here is this is what you call a heating or cooling curve. And what you have on the vertical axis or the y-axis is the temperature, and the heat entering the system is on the x-axis. Now, in some books and in some, so you have here, come on. All right. In some books, what you have is we can actually, in some books, they have this as time. No, let me see. My pen doesn't seem to be working right now. That's okay. We will reset it. Okay. Now, what we have here is you can have time. Now, so what you will notice is that a heating or cooling curve of a pure substance, what you will get is you will get these plateaus. And these plateaus is where we have our phase changes. And what you will notice is during those phase changes, the temperature remains constant. Now, let me give you an example here. So let's say if we were to use example, I don't know, let's say we had water. Now, water, I'm using water because we are very familiar with it. It has a specific melting and freezing point of 0 and a specific boiling point of 100 degrees Celsius. Now, for pure water, what happens is when water is melting, because it's undergoing a phase change, if you stick a thermometer into a ice water, and it will remain a constant 0 degrees Celsius. Same thing if you're boiling water. What happens is if you stick a thermometer into boiling water, what happens is that it will stay at 100 degrees Celsius because all the energy that you are adding into the water is being used for phase changing. Okay. Now, once the phase change is over, so let's say you either have gas or liquid or solid, what happens then is you get the temperature increasing because all the energy is being used to excite the particles, is to make the particles move faster. Okay, so that is why when you have a phase change going from solid to liquid or liquid to solid, liquid to gas or gas to liquid, what happens is you have a constant temperature because all the energy is being used to change the substance from one phase to the other. Now, if you take a look at the right-hand side, you will see what I have is a list of all of the names for the different phase change. So freezing is from liquid to solid, melting is from solid to liquid. Now, one thing you will notice here is boiling and evaporation. Notice they are both liquid to gas. So what is the difference between boiling and evaporation? Evaporation is liquid to gas at the surface. And can be at any temperature. Boiling, on the other hand, is liquid to gas everywhere. And is at specific temperature. Now, if we were to use water, let me give you an example of a difference between evaporation and boiling. Evaporation is liquid to gas at the surface. This is how your clothes dry. So when you do your laundry and you stick your wet clothes into a dryer, what happens is that it is drying via evaporation and it can occur at any temperature. That is how your clothes dry. So the heat in the dryer is not 100 degrees Celsius. It might be 40, 50, 60 degrees Celsius, a little bit warmer. And what this does is that it speeds up evaporation of the water from your clothes at the surface. And this is how your clothes dry. Boiling, at the other hand, is liquid to gas everywhere and it's at a specific temperature. So for example, boiling water. Boiling water, you notice there's bubbles throughout the entire pot or cup, and it's forming everywhere. And that's because everywhere where it reaches 100 degrees Celsius, that is where the water is going from liquid to gas. Now, this is why you will notice that bubbles form closest to the bottom of a pot when you're boiling water, is because closest to the heat surface or to the heat source, that is where you get the temperature reaching 100 degrees the fastest. And this is why you have bubbles forming at the bottom of a pot when you put it on a stove. Okay, so that is the difference between the two. Now, you might say, well, Mr. Chan, what about the steam that comes off the pot before it hits 100 degrees Celsius? Well, the steam that comes out of a pot before it hits 100 degrees Celsius is evaporation because it is liquid to gas at the surface. Now, there is two phase changes that some of you may not be familiar with, is sublimation and deposition. Sublimation is solid to gas and deposition is gas to solid. Now, the components of a pure substance cannot be physically separated, and a chemical change is needed to change the characteristics of a pure substance. Okay, so in this case, when you're boiling water, you're not changing the chemical characteristics of water. It's just going from liquid to gas or from solid to liquid. The characteristics stay exactly the same. So this is why we call it a physical change. Now, notice this energy is needed to affect the phase change, and there's a specific terminology that is used. For melting, what we call the energy used to melt a substance is called the heat of fusion. So heat of fusion is the energy or heat required to melt a substance. And you have something called heat of vaporization. Heat energy required to evaporate a solute substance at its boiling point. So you can think of it, heat of vaporization is the energy required to change a liquid into a vapor. Now, if you are in Chemistry 11 honors, we'll be talking more about this. If you're just in regular Chemistry 11, what we're doing is just be aware of the terminology. Now, for mixtures, the heating and cooling curves change depending on the composition of the mixture. Therefore, it doesn't have a unique curve like a pure substance. Now, let me give you an example here. So let's say we have salt water. So example, salt water. Now, all of you know that salt water is just a mixture of salt and water. Now, if we were to take a look at the heating curves of salt and water, it might look something like this. So water we had just talked about before. So let's say this is water. Remember, we talked about 0 degrees Celsius and 100 degrees Celsius is where water changes phases, okay? But for salt, because salt is different, if we take a look at salt, salt might be something like this. It doesn't phase change until, let's say, I don't know, 600 degrees Celsius. So when you take a look at this graph, what you will notice is that when water changes phases, salt is still heating up. All right, at 0 degrees and at 100 degrees, while water is changing phases, the salt is still heating up. Now, when salt finally changes phases, you notice here, water is heating up. So what happens is there is no matching time in which they are changing phases. And so what happens is you get sort of a straight line graph here, a straight line in terms of the heating curve. Of the mixture, because it's sort of like a compromise between the two. Okay. Now, because mixtures retain or keep their own characteristics, they can be separated by several techniques. One is hand separation, literally picking the components apart. The other one is by filtration, where you filter solids from liquids, like your coffee grinds. The reason why filtration works is because of the fact that coffee, the solids retain their own characteristics, and the water retains their own characteristics. Distillation is where you apply heat to a mixture so that one of the components boils and evaporates before the other. Okay. That uses the concept of where you don't have the same phase changes for two different substances. So one will change phases first before the other. And that's what we call distillation. Now, in the link below, what I would like you to do is take a look at the distillation demonstration that illustrates the point where you can separate two liquids due to their different temperatures in which they change phases. Okay. Now, the other one is gravity separation, where the components are separated based on their density, like blood. And the other one is paper chromatography. Paper chromatography uses the fact that some substances move faster than others in a solvent like water, and therefore are able to be separated. Okay, again, in the link below, please click on the YouTube link to see what the chromatography looks like. All right, folks. Thank you. Have a good day. Talk to you soon. Bye-bye.